Question number 9. Okay. So what's the doubt here? So I have my f of x equals to x square plus 1 by x square, right? So you guys can hear me, right?
Yes, sir. Actually, the doubt was I was not able to find the infimum or the supremum there.
Okay. What is supremum?
The highest
All right, the highest. Very good. So how do you find the highest of any function?
by differentiating
So what is the differentiation of this function?
2x plus x plus my 2 upon x cube.
2x plus
2 upon x cube.
2 upon x cube. Are you sure?
Just a moment, sir.
Alam, would you like to?
Minus 2 upon x cube.
Minus 2 upon x cube. Right. So this is the f prime. All right. Now, all right. So my function is x plus 1 by x square. All right, 2x plus 1 by 2 by x cube. So where is this thing positive? Where is this thing going to be positive? Remember that the domain is just 0 to 1. All right, so the domain is only given as 0 to 1. Sorry, 0 to infinity. So only in the positive sphere. So you don't need to consider negative x. So in the positive space, where is this f prime going to be positive?
Sir, in the negative region, that is after minus 1.
I just said that x has to be positive only. So
1,
don't
1 to infinity.
1 to infinity. So f prime is positive for x belonging x greater than 1, f prime is positive. And by similar logic, for x less than 1, f prime is negative. Right. So this function is decreasing till 1. So I am only going to consider in 0 to 1. Right. Plus this is x square plus 1 by x square. Both these quantities are themselves positive. So the f value is always going to be positive. X has already he's already told you to be positive. So this function is going to be decreasing till 1. This is x equals to 1. So till 1 it's going to be decreasing, right? And after 1 it's going to be increasing. And it keeps on increasing, right? So f prime is positive for all values greater than 1. So it keeps on increasing, right? So it keeps increasing here and it will keep increasing here. Then the question is, does it achieve any limit? That becomes the next question. So what is limit x tending to 0 plus x square plus 1 by x square? What is this limit?
Sir, infinity.
Infinity, very good. So it goes to infinity here. And what is limit x tending to infinity x square plus 1 by x square?
It's still infinite.
Infinity. So this function is going to infinity here, going to infinity here. So there is no maximum. So there exists no supremum for this function. So there is no supremum. But I know that f prime equals to 0 happens at x equals to 1, right? So if you substitute x equals to 1 in this particular thing, you will get in this thing, you will get f prime 0. So that is this point. This point is your minimum. And so this point 1, this is where f attains its minimum, and hence the infimum. Okay, so f is going to attain its minimum and its infimum at this point, which is x equals to 1. So between 0 and 1, it's going to achieve its minimum.
Sir,
Yeah,
in this it is given, it is infimum on the set 0 to infinity,
yeah.
but it is just an infimum on the point 1. So, can it be considered an infimum on all the
No, no,
set?
no. This means that the infimum is some point in this set 0 to 1, the 0 to infinity. So it just means, okay, so just copy this thing. Mm, yeah. So what this means is that uh, at some point on this in this set, infimum is achieved. This is what it means. It does not mean that it achieves its infimum on every point. It just means that it achieves its infimum at some point on this set. This x square, obviously, I mean, by your logic, none of these options can be correct, right? So if you go by that logic, if you interpret it like the question means that in all points on 0 to infinity are infimum, then by that logic, none of the options are correct. That cannot happen, right? One of the options has to be correct. So you cannot go ahead with that interpretation. So sometimes you can get some ambiguity in question. That happens. This year ISI has, last year ISI's question paper had 4 questions which were wrong. So if ISI can make some mistakes, then definitely my test would also have that ambiguity. But that ambiguity is resolved here if you look at the options. Right? So this question does not have that ambiguity right now. Next,
Sir, no doubts from this test.
Sir, question number
Alam,
4.
question number 4. Okay. If a randomly chosen student is asked 2 distinct randomly chosen questions from the test, okay, first I have to look at the paragraph. Okay. Out of 14 students taking a test, 5 are well prepared, 6 are adequately prepared, and 3 are poorly prepared. So out of 14 students in total, I have 5 who are well prepared, 6 who are adequately prepared, and 3 who are poorly prepared. There are 10 questions. 10 questions. A well prepared student can answer 9 questions correctly. So this guy answers 9 questions correctly. An adequately prepared can answer 6 questions correctly. and a poorly prepared student can only answer three questions correctly. If a randomly chosen student is asked two distinct randomly chosen questions from the test, what is the probability that the student will answer both questions correctly? Correct? Oh, so yeah, so you have a randomly chosen student who's asked two randomly chosen questions. Okay, so with 5 by, so first of all I have to find the probability that a well prepared student, sorry, both questions correct given that the student is well prepared. Okay, so what is the probability that a well prepared student can answer both questions correctly? uh, so this probability is going to be that you are randomly choosing, so he knows the answers to 9 questions, right? Out 9 out of 10 questions he knows. It is just one question that he doesn't know. So if you choose any of these 9 questions, so 9C2 by 10C2 is the probability that you have chosen a question, both questions which this guy knows. Then he's going to answer them with probability 1, right? Plus, uh, okay, yeah. So this is basically the probability that this guy is going to prepare, this guy can answer the questions correctly, right? So this is probability of questions correct given uh, that this guy is well prepared. Now probability that two questions correct given adequately prepared candidate, by same logic, since the adequately prepared candidate can give 6 questions correct answer, so this is going to be 6C2 by 10C2, and probability of two questions correct given poorly prepared candidate is going to be 3C2 by 10C2. Okay, so what the question asks me is, what is the probability that the student will answer both questions correctly? All right, so the probability of a well prepared student is 5 by 14. This probability is 6 by 14, and this probability is 3 by 14. So the final probability becomes uh, 5 by 14 into 9C2 by 10C2 plus 6 by 14 into 6C2 by 10C2 plus 3 by 14 into 3C2 by 10C2. And then this is just, after that, it's just maths. Right? Okay.
Okay, sir.
All right. Next. Should I move to the next test?
Yes, sir.
All right. DSE Mock 2. Yeah, tell me which question number.
Sir, question 1.
Question 1. Mm, okay. 1 plus 2 plus 4. Okay, okay. Mm, okay, there's a sequence here. Just forget the first number. Focus on this. 1, 2, 4. Next is 4, 6, 9. Okay. And so on it goes till it reaches 361, 380, and 400. So if you look at this particular thing, this is basically 2 square, 3 square, and so on till 20 square. Okay. If you look at these numbers, okay, so these are 1 square, 2 square till 19 square. And these intermediate things, right? So these are 2, 6, and 380. So 380 is 19 into 20. Okay, so this is 2 into 1. 2 is 2 into 1. 6 is 3 into 2. And that's how you go till 380, which is equal to 19 into 20. So this thing is multiplication of two consecutive squares. So if I were to write this first thing, this would be n square plus n into n plus 1 plus n plus 1 square, right? For n equals to 1, this becomes for n equals to 1, and this becomes the same thing for n equals to 19. So this is just summation n square plus n into n plus 1 plus n plus 1 square, right? So that is what we have here. If you can see this on the, can you see my cursor, by the way?
Sir, no, not the cursor.
No, okay, fine. So, but you can see the solution. So, on the solution bit, I have written the same thing, going from n equals to 1 to 19. This is just this thing. Okay. After this, how you resolve is, it is completely up to you. So, you can use the expansion of n square. So, or you can use it, go in this manner that is given in the solution. Now, assuming that you don't know this expansion, you can even use expansion of n square. So what is expansion of n square? What is summation n square?
Sir, n bracket by n plus 1 फिर bracket में 2n plus 1 by 6.
Right. So this is n into n plus 1 into 2n plus 1 by 6. Similarly, so now this n plus 1 square will be equal to n into n plus, sorry, n plus 1 into n plus 2 into 2n plus 3 upon 6. Right. But in this case, in n plus 1 square, you notice that uh, Yeah, fine. No. N is going from 1 to 19, right? So after that, you can just take things common and you can expand it. So you basically have some. mm, yeah. So the first thing is n into n plus 1 into 2n plus 1 by 6 plus n into n plus 1 plus n plus 1 into n plus 2 into 2n plus 3 by 6, and you have a 1 to begin with. You have a 1 to begin with, so you can just use the expansion and find the final value. So what is the value of n that you're going to substitute here, by the way?
Sir, 19.
Very good, 19. Okay, so that is what it is, the last value that we have in the summation. So that is 19, not 20. So that is also crucial. So you should not make a mistake there. Mm. All right, fine. Uh, so when you do that expansion, you should be able to get this because it's just algebra, right? So either way, whatever technique you follow, you should get the same answer. So if you follow this routine, you will also reach. You should also reach 8,000. All right, what next?
Sir, question to
It's not too, not too, not too. Okay. What question number?
12.
3030? 12. Okay, 1 to 12. This is 10. It should be in micro. It's the haircuts question. Tanvi, just to clarify, it's the haircuts question, right?
No, sir. After this.
The second question in the paragraph. How much time will he dedicate for haircuts?
No, next.
Next one. What is the amount of hours capital T he should work so as to maximize the profit?
After this whole question.
Okay, so this 3 plants question.
No. Wait, sir. Is sir, it is the 12th question in micro.
Okay, question number 12 in macro. Okay. There are 25
Next.
potential used car buyers, each of whom is willing to pay $1,200 for a good car and $400 for a bad used car. Okay, so you have two types of cars here in this market: the good car and the bad car. Right. So for the good car, uh, the buyers are willing to pay $1,200, but for the bad car, they are only willing to pay $400. So potential buyers want to buy at most one car before they purchase a used car. Buyers are not able to tell whether it's a good used car or a lemon. A market for lemons is basically a very popular paper where in these kind of scenarios are discussed, where there's a market wherein used products are being sold. So the current owners of good used cars have a reservation price of 300 700 for their car. So good cars cost reservation price is $700, so they don't send it above 700. and the current owners of lemons have a reservation price of 200. So bad cars ke liye, the reservation price is 200. In this market, there are 5 good used cars and 15 lemons. So number of good cars is 5 and number of bad cars is 15. So you're saying question number 12. How many more good used cars need to be added to the market to make the owners of good used cars supplying to the market? All right. So what happens is that right now, customers cannot differentiate between what's a good car and what's a bad car. All right. So if suppose all the cars were to enter the market, then my probability of getting a good car will be equal to 5 by 20, which is basically 1 by 4 if all the good cars were in the market. And my probability of getting a bad car will be the remaining probability, so that is 3 by 4. So the expected utility of the buyer, with 1 by 4 probability he gets a utility of 1200, and with 3 by 4 probability he gets a utility of 400. Okay, so that is basically 300 plus 300. So this is 600. So he is only willing to pay 600 if all the good cars are in the market. But if he's only willing to pay 600, which is less than the reservation price of the good car seller. Right. So the expected utility of buyer is less than the reservation price of a good car seller, 700. So what happens is that he knows that so none of the good car sellers are going to sell in this market. All right. So what happens is that these people, they do not enter the market at all. So the 12th question asks me, in how many more good cars need to be added to the market to make the owners of good used cars supplying to the market. So I want this expected. So suppose there are n more good cars added to the market, 5 plus n. So the probability of good cars now becomes 5 plus n by 20 plus n, and probability of bad cars becomes 20 by 20 plus n. No, sorry, 15 by 20 plus n. So in this case, I need that the expected utility of the buyer should be greater than 700. If that happens, as soon as that happens, my good car, my expected utility of buyers is higher, so good car owners will be willing to sell in the market. Okay, so let's calculate that. So that will now become this becomes just 5 plus n by 20 plus n into 1200 plus 15 by 20 plus n into 400. This should be greater than 700. So this implies 1200 into 5 plus n plus 6000 must be greater than 700 times 20 plus n. Okay, so this is 6000 plus 1200 n plus 6000 must be greater than 14,000 plus 700 n. So this implies what? This implies that 12,000. So this implies 500n should be greater than 2000, which implies n must be greater than 4. So n was the number of new cars which need to be added. So at 4 new cars, they become indifferent between selling or not selling. So n greater than equals to 4. Actual answer should be n greater than 4, but a lot of times people get confused. So that's why in the options, I have not added 5 at all here. Because if I add 5, then it becomes confusing that should 5 be the correct answer? Because at 4, everybody is indifferent between adding or not adding. So the Nash equilibrium at 4 is very complicated. So it becomes confusing. So that's why in questions like this, it's best not to give answers greater than 4, because then it becomes amply clear that the only correct answer has to be 4. Okay.
Yes, sir.
All right. Next. No more doubts.
Sir, question 4 of macro.
Okay. So household's disposable income is given by YT tilde equals to 1 minus tau WTLT plus RTKT, where tau is the income tax rate. WT is the wage rate, RT is the rental rate for capital. A firm side is competitive with Cobb Douglas production function. Suppose household chooses saving according to ST is equals to S Y tilde T, and capital stock accumulates as give me a second, there's somebody at the door. Just muting. Be back in 2 minutes. Yeah, sorry. Can you guys hear me? Hello.
Yes, sir, we can hear you.
Okay, fine. Uh, please, Pretty irritating. Macro question number. Okay, which question did we have a doubt in? Yes. Tanvi, are you with us? Tanvi? Has Tanvi left? I can still see her.
Sir, I think she took 2 minute break.
All right, fine. Do you have any doubts in the meantime?
No, sir.
No, okay, so let's just wait for Tanvi and let
I think this
me.
question she will talk about.
Yeah, she was talking about this question, but I don't remember which part in this question because it has what, 6 parts in it.
Fourth part, I think.
Okay, fourth part. All right, fine. So we have um,
Sir, when will you take econometrics classes?
um, I'm coming back from. I'm going home for next week, but I can take next week. So I'm thinking from 16 to 28 we can take the classes. So it will take me around 3 more classes for econometrics.
Okay, sir.
Okay, I'm okay. Anyway, let's do this, and maybe I'll share the recording with her. So we have this as our income. Then savings is equals to some fraction smallest of my income, which also becomes investment in time period T. So capital in time period T plus 1 is the capital remaining after depreciation plus the new investment which happens. All right. So here you can modify this thing. This is 1 minus delta times kt plus savings times 1 minus tau. You can basically write this function here. We can write this entire thing here, right? So it will become something blah blah blah. Right? Okay, I'll have to write this thing. So this becomes 1 minus delta times kt plus s times 1 minus tau wt lt plus rt kt. Right? Okay. All right. Furthermore, it's given to me that my production function is yt is equals to kt to power alpha into at lt to the power 1 minus alpha. So from this 1, I know that so I need to replace this thing here, WTLT plus RTKT. Okay. So the profit function of the firm is YT minus WTLT minus RTKT. Right. So would actually follow from the earlier result. So if you use the earlier result, so the result, this is actually solved in the previous one. In our previous one, in the third question, we have YT tilde is equals to 1 minus tau into 1 minus alpha plus alpha times kt to power alpha into AT to power 1 minus alpha. So this is what needs to be substituted here. YT tilde. So that will give me my kt plus 1 to be equal to 1 minus delta times kt plus s times 1 minus tau into 1 minus alpha plus alpha times kt to power alpha into AT to power 1 minus alpha. Okay, this will come from part 3. If you have done part 3, then this should be here. Okay, so now that I have my kt plus 1, after that I just need to get it to steady state. So let me divide this by ATLT. So if I divide by ATLT, what I get is KT plus 1 by ATLT is equals to 1 minus delta times KT by ATLT plus S into 1 minus tau into 1 minus alpha plus alpha times into KT to power alpha by ATLT to power alpha. You see this ATLT to power 1 minus alpha will cancel out with ATLT to power 1 minus alpha. So you'll be left with this entire thing to the power alpha. Right. So so then you can write capital KT upon capital AT into LT is equals to small capital T. So what I get is that small capital T, something keeps happening. 1 minus delta times small capital T plus S into 1 minus tau. Oh no, this is not that time. This is okay. This remains as it is. KT plus 1 by ATLT is equals to 1 minus delta KT plus S into 1 minus delta into 1 minus alpha plus alpha times small kt to the power alpha. Right. Okay. Let me call this entire thing as S prime. So this function just becomes 1 minus delta small kt plus S prime small kt to the power alpha. Right. All right. Now kt plus 1 what is kt plus 1? Kt plus 1 will be equal to capital Kt plus 1 upon At plus 1 into Lt plus 1, which is equal to Kt plus 1 upon At into 1 plus G multiplied by Lt into 1 plus N. Okay. So this implies that Kt plus 1 upon At into Lt must be equal to small kt plus 1 into 1 plus G into 1 plus N. Right? So I can make this substitution here. So what I'll get is that small kt plus 1 must be into 1 plus G into 1 plus N must be equal to 1 minus delta times small kt plus S bar small kt to power alpha. Right. Now in steady state, this small kt must be constant. So you should have this kt plus 1. So you should have this small kt plus 1, this small kt and this kt to power alpha all as your k star. So what you get is k star into 1 plus G plus N. So this is the short form, must be equal to k star into 1 plus 1 minus delta plus S bar into k star to power alpha. So then you can write k star into N plus G plus delta. Okay, you can cancel these things out. This is approximation. Ideally, 1 plus G into 1 plus N would be what? 1 plus G plus N plus NG. Right? But I'm using approximation here. I'm using Ng equals to 0 because G and N are small quantities like 0.1, 0.02 type of things. So N into G will be almost 0. So N plus G plus delta, this must be equal to S bar into K star. So this implies, sorry, K star to power alpha. This implies K star to power 1 minus alpha must be equal to S bar by N plus G plus delta. Okay. So K star must be equals to S bar upon N plus G plus delta whole to power 1 upon 1 minus alpha. Okay. I hope that's okay with you, Tanvi, wherever you are. Okay. Is she back? No, she's not. I don't know if you're back, Tanvi. Do we have any more doubts?
No, sir.
All right, fine then. I'll stop sharing my screen. Cool. So if you need any other sort of help, you can let me know. I'll be taking those equatrix lectures this week, most probably. I'll ask others if they're okay with the lectures. I think they should be. Anyway, everybody watches recordings. So I'll take those lectures this week, and then I'll keep sharing more tests.
Sir, please
Okay.
share the recording to this session also.
Yeah, sure. I'll do that. It will take me some time because Zoom sends it after some time, but I'll share the recording.
Sir, actually, I need some practice questions for stats.
Have you done? I don't know. Which book were we doing? We were doing Dig Root, I think,
Yes.
right? So have you done Dig Root again?
Sir, no, I
I
have
think
saw
Dig
it
Root.
just once.
See, the thing is that everything that there is in any test will be some modification of what's there in Dig Root. Dig Root has all sorts of questions in it. If you do Dig Root, then there would be like it's hard to find something which is very new. I mean, I can recommend you other books. There's one more book which I was probably sharing with you guys. Maybe it is already uploaded, but the point is that the questions will be similar, the numbers will be different, so you'll not learn much from it. So that's why I keep saying instead of trying to look for more and more problems, try to do the same problems again and again. That would be better. So try doing dig root once more, okay? Because I am good at dig root. So if you have doubts from dig root, it will take me less time to handle it. Uh, so if it's taking me less time, I can definitely do a good job for you as well. So that's in your benefit as well. So try to do dig root, and if you have any specific doubt that can't you find that okay, I've not covered this topic because I have omitted some topics from dig root. It's a big book. We cannot do everything. We have done like 8 or 9 chapters. There are like 25 odd chapters. So if you feel that there's something which is being asked which is not covered, then definitely consult me. If I feel that it is something that needs to be taught, I will
Uh,
teach.
i- so one topic, the relation topic, you taught us in the real analysis unit. Last year DSE asked the relation question, 5 questions, and those questions were pretty tough, and it was out of my mind when I read those.
Which questions can you
It was from topic real analysis.
real analysis? Yeah. Let
The
me
the
open.
relation topic, the relation question, which asks the relations, negations, and transitive properties. We have to prove
Yeah,
the
yeah, yeah. So they are
those
not
questions.
very difficult. The point is, mm, they seem difficult because you cannot apply maths in them. Let me open that paper. Let me search for that paper. Mm, where is that paper?
Should I WhatsApp you the paper?
No, I have the paper. I'm looking for the question. I have the paper. I'm looking for one of these questions. Okay, this is about, yeah. So this is one of the questions. The let negation denote let the negation of a statement. Let me open the notes. So there's one question on negation and irreflexivity and stuff like that.
So they
Hmm.
ask 5 questions on this topic.
Yeah. I see that. This is very weird for DSE actually. They usually ask 1 or 2 questions. 5 questions from one topic is too weird. Uh, Let me see if I can find some good source on this. The problem is that these are things which you will be taught at your master's level. So I don't know how to teach you all these stuff right now, because I mean I will be practically doing half semester worth of microeconomics if we have to do all this. But they are not asking everything. That's the thing. They are not asking everything. The problem is what they are asking is a subset of what is being taught in first year micro. But they are sticking particularly to just you knowing transitivity and that is actually sufficient. If you know transitivity, and that is like more than enough. The my conundrum here is that I cannot teach you everything. So I have to find a source or maybe build up a source which which does not uh, get too technical. So while being easy, we should be able to do these problems. So let me find some good sources on this online and let me get back to you. Okay.
Okay, sir.
All right. Thanks for pointing this out. I mean, I've seen the paper, but I didn't realize at that point of time that they asked so many questions on this topic. This is 10% of the paper. That's huge. Anyway, so let me go through this and I'll discuss it maybe August end. Yeah. All right. Fine. Okay, guys. I'll see you guys next week with econometrics. Okay.
Thank you, sir.
All right. Sure. Bye. Welcome.